You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Welcome to the Bare Metal Cyber Server Plus Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Domain 1 of the Server Plus exam introduces the physical layer of server deployment, everything that must be addressed before software is installed or services are configured. This includes tasks such as mounting servers in racks, providing adequate and redundant power, ensuring cooling and thermal balance, securing heavy equipment, managing cables, and selecting the correct internal and external components. The knowledge covered in this domain is the operational backbone of any server environment. The Server Plus exam treats physical setup not as an optional task, but as the foundation upon which all other domains depend. Mismanaged airflow, mismatched power ratings, or improperly secured equipment can lead to overheating, shutdowns, hardware damage, or even personnel injury. This domain is about building systems that are physically safe, electrically sound, and thermally stable, and doing so in a way that supports long-term maintenance and scalability. Let's begin by exploring rack sizing, a core concept in any server deployment. Server racks are measured in vertical units, abbreviated as U. One rack unit equals 1.75 inches of vertical space. This standardization allows equipment from different manufacturers to be installed within the same rack infrastructure. Most commercial racks range from 24U to 48U in total height, with 42U being among the most common for data center use. Knowing how to calculate space within a rack is critical for planning. For instance, if each server takes up 2U of vertical space and your enclosure is 42U tall, you might expect to fit 21 servers. But in practice, you also need to account for horizontal PDUs, cable organizers, blanking panels, and required gaps for cooling. Server Plus expects you to think beyond raw math and consider layout constraints. Rack layout planning affects more than just spacing. It determines accessibility, stability, and cooling efficiency. Equipment must be arranged in a way that supports front-to-back airflow, which is the standard cooling direction for most enterprise-class servers. Devices that require frequent service should be mounted between waist and shoulder height, while heavier components must be mounted near the bottom of the rack to lower the center of gravity and prevent tipping. This leads directly to the topic of airflow, which introduces the concept of hot aisle and cold aisle configurations. In properly managed server environments, racks are arranged in rows where the front sides of all racks face one aisle and the rear sides face another. The aisle with front-facing intake vents becomes the cold aisle, where cool air is supplied by the HVAC system. The aisle behind the racks becomes the hot aisle, where exhaust heat is expelled. This pattern promotes efficient thermal movement and prevents hot and cold air from mixing. Thermal zoning refers to the strategic placement of equipment within a rack based on its thermal output. Not all devices produce the same amount of heat. A high-performance database server may emit more thermal energy than a simple network switch. If two high-heat devices are placed directly above or below each other, they can create a localized hot zone where airflow cannot keep up. Thermal zoning addresses this by spacing out high-heat components, using blanking panels between devices, and managing airflow with fan trays or ducting to maintain balanced thermal conditions. Ignoring airflow and thermal zoning shortens hardware life and leads to increased cooling costs. Overheated servers may throttle performance or trigger thermal shutdowns. Exam questions in this domain may ask you to identify consequences of improper thermal design or recommend best practices to mitigate airflow conflicts. In the field, poor airflow management often results in erratic system behavior that gets mistakenly blamed on software or drivers. Next, let's look at safety protocols during physical installation. Rack-mounted equipment is often heavy, with some servers weighing over 30 pounds. Improper lifting can cause injury to personnel or damage to equipment. Technicians must be trained in lifting techniques, such as using their legs instead of their back, and using two-person lifts for heavier systems. Racks should be assembled with anti-tip feet or anchored to the floor before being loaded with gear. Floor load calculations are another consideration that goes beyond the rack itself. A fully loaded rack can weigh over 1,000 pounds. In a multi-floor office building, not every floor can safely support this weight. Server Plus expects you to recognize when floor load ratings should be verified, especially when racks are deployed in older buildings or in rooms originally intended for office furniture, not data center equipment. Power distribution units, abbreviated as PDS, are used to deliver power to multiple devices inside the server rack. There are several types of PDS, including basic models that simply provide outlets, and more advanced metered or switched models that monitor energy usage and can be controlled remotely. PDUs can be mounted horizontally in the rack or vertically along the side rails. Their format and power capabilities must match the devices they serve. Selecting the correct PDU depends on several factors, including voltage, amperage, and plug compatibility. For instance, a rack full of high-performance blade servers may require multiple three-phase PDUs with high amperage ratings. Using an underpowered PDU may result in circuit overload or inconsistent power delivery. Additionally, the plug type must match the input connector on the server power supply. Common standards include IEC C13 and C19, as well as regional plug formats like NEMA5-15. Keyboard video mouse switches, or KVM switches, allow a single administrator to control multiple servers through one set of input and display devices. Local K versus Ms are physically installed in the rack and include a fold-down keyboard and monitor. IP-based K versus Ms allow remote access over the network, which is essential when managing servers in remote or high-security environments. K versus Ms must be installed where they can be accessed quickly, especially in emergencies when remote access fails. Rail kits are another physical installation element that directly affects serviceability. Servers are not simply placed on a shelf. They are mounted using rails that align with the rack's side posts. Fixed rail kits hold the server firmly in place, while sliding rail kits allow it to be pulled forward for inspection or component replacement without fully removing it from the rack. Toolless rails reduce installation time but require compatibility with both the server chassis and the rack's mounting pattern. Redundant power is a best practice in most enterprise environments. Many servers are equipped with dual power supplies, each capable of independently powering the system. These power supplies should be connected to separate PDUs, which in turn are on different circuits or even different electrical grids. Some facilities also use two different internet providers to prevent connectivity failure during a regional outage. Server Plus expects you to understand not only what redundancy is, but how to design for it using separate feeds, multiple UPS units, and dual-homed connections. Power connectors come in multiple formats, and selecting the wrong one can cause power issues or damage hardware. International standards like IEC and regional codes like NEMA define connector shapes, grounding pins, and current limits. For example, an IEC C13 plug is used for low-power devices like monitors, while an IEC C19 connector supports higher amperage needed by enterprise servers. Choosing the wrong connector may result in a failure to power on or, worse, permanent hardware damage due to overheating or arcing. Cable management is not just about aesthetics, it is a critical part of airflow and serviceability. Power and network cables should be routed separately to avoid signal interference. Velcro straps, not zip ties, should be used to bundle cables, as they are easier to remove and less likely to damage insulation. Cables should be labeled clearly on both ends to speed up tracing and prevent errors during replacement or reconfiguration. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Redundant networking is a core concept in server environments that cannot afford downtime. This involves using more than one physical network path to ensure continuous connectivity. If one cable is accidentally disconnected or one switch fails, the server can continue communicating through the alternate path. Redundancy reduces single points of failure and is considered a best practice in both production and staging networks. There are multiple techniques used to implement redundant networking. One common method is NIC teaming, where two or more network interface cards are logically grouped to act as a single interface. This configuration provides load balancing and failover capabilities. Another approach is link aggregation, which combines multiple physical links into one logical channel, increasing both throughput and fault tolerance. Cable types are also important when designing a resilient and high-performance network. Twisted pair cables, such as those used in Ethernet, consist of copper wires twisted together to reduce electromagnetic interference. They are cost-effective, easy to install, and sufficient for most short-distance connections. Fiber optic cables, on the other hand, use light to transmit data and are ideal for high-speed, long-distance connections. Server Plus candidates must understand the trade-offs between twisted pair and fiber. Twisted pair is easier to terminate and install, but is limited in both distance and speed. Fiber offers faster throughput and greater resistance to interference, but is more expensive and requires specialized tools. Knowing when to choose one over the other is essential for exam success and real-world planning. Connector types also differ between fiber cable types. The standard connector, or SC, is known for its push-pull design and is commonly used in older installations. The Lucent connector, or LC, is smaller and supports higher port density, making it ideal for modern data centers. Fiber cables are also categorized by mode. Single-mode fiber is designed for long distances with a narrow core and uses a laser light source. Multi-mode fiber has a wider core and is better for short runs and local area networking using LEDs. Transceiver compatibility plays a role in fiber installation as well. The connectors must match both the cable type and the form factor of the transceivers in your switches or routers. Using the wrong connector or mode type can result in poor performance or no connection at all. Server Plus includes this topic to ensure candidates can match fiber types and connectors correctly during hardware installation. High-speed networking interfaces appear often on modern servers and switches. Gigabit Ethernet supports speeds of up to 1,000 megabits per second, while 10 gigabit Ethernet increases that to 10,000. These speeds are delivered through copper or fiber depending on distance, cable type, and the device's interface. Understanding the characteristics of each helps when selecting the right transceiver or switch module. Small form factor pluggable modules, abbreviated as SFP, and their successors like SFP Plus and Quad SFP, allow administrators to install the appropriate connection interface into a switch or network card. These transceivers are hot swappable and modular, making it easy to change connection types without replacing the entire device. They are often used in environments where flexibility and future upgrades are required. Cable management for networking is just as critical as for power. Structured cabling is the organized and standardized method of routing cables in a server room or data center. It includes components like patch panels, cable trays, and conduits. Organized cabling not only looks better but reduces electromagnetic interference, makes troubleshooting easier, and supports cleaner airflow within racks. Labeling practices should be implemented from the start of any cabling job. Each end of a cable should be labeled clearly to indicate its origin and destination. Color coding is also common, for example using blue for user access ports and red for critical uplinks. These small details make it significantly easier to perform maintenance, trace faults, and expand networks later without confusion or delay. Chassis types refer to the physical form factor of the server. There are three primary categories: tower, rack-mounted, and blade. Tower servers look like desktop PCs and are often used in small offices. Rack-mounted servers are designed to fit in standard racks and offer better density and cooling. Blade servers are even more compact, sliding into a shared enclosure that provides power, cooling, and connectivity for multiple blades. Each chassis type has its own use case. Tower servers are affordable and easy to install, but they are bulky and difficult to scale. Rack-mounted servers are the most common in mid-sized environments due to their modular design. Blade systems offer the highest density and efficiency, but require a significant upfront investment. Choosing the right form factor depends on physical space, budget, and performance needs. The internal components of a server directly affect its performance and scalability. The Central Processing Unit, or CPU, performs the main calculations and runs the server's operating system and applications. Random Access Memory, or RAM, holds active data and application code for fast access. Bus types such as Peripheral Component Interconnect, or PCI, determine how data flows between the CPU, storage, and expansion cards. Understanding how these internal components work together helps administrators plan for future upgrades. A slow bus will limit the performance of even the fastest CPU or storage system. RAM capacity determines how many users or applications can run simultaneously. These details are covered in Server Plus to ensure candidates know how to choose the right specifications during the procurement or design phase. Mastering Domain 1 means you understand how to physically build and configure a server system that is stable, secure, and serviceable. It prepares you to plan infrastructure, respond to hardware failures, and scale systems efficiently. These skills directly support advanced topics in administration, virtualization, security, and troubleshooting, making this domain one of the most critical on the Server Plus exam. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.